everyone, this is part 2 of our particle motion video, and really this is in case you weren't in class or just want to watch this again. So again, we're talking about particle motion, and this time we're going to be working with a function for velocity. So if the problem gave you an actual function, and you can tell this is a calculator problem, so it would be good to have your calculator ready. So here we go. I see a particle motion, or a particle moves along the x-axis with this given velocity, and my interval is between 0 and 3.5. They're also giving us an initial position here. So x equals -5 at time t equals 0 is our initial position. Now, because this is a messy function, and I assume we're going to be using it a lot, I'm going to go ahead first and put that in my y equals. So I'm going to get myself a fraction. On top, I've got 10 times the sine of 0.4 x squared. And on bottom, I've got x squared minus x plus 3. So I've got it there so I don't have to retype it in every problem. So let's see what we need to do with this. The first thing says find the acceleration of the particle at time t equals 3. So I know I'm looking for acceleration at times 3. I also know that's just the first derivative of velocity. So here's what I'm going to do. I'm looking for a derivative of velocity. So I'm going to do math 8. That gives me my derivative. I'm going to take the derivative with respect to x. Now here I'm going to go to vars, hit that key. I'm going to go over to yvars, hit enter for function, and I'm going to select y1 because that's where I have this stored. So that's going to pop that in there. I don't have to retype my velocity function. Now I want to evaluate this at x equals 3, and so I'm going to hit enter, and I get -2.118. Actually, it's approximately -2.118. Now, one thing I want to bring up in this particular problem is that usually we really emphasize units. However, if the problem does not give you units, do not make units up. Just leave your answer without units. You never want to insert units into a problem where they haven't been given to you. All right, so for the next part, it says find the position of the particle at this time. Well, we know when we're finding the position, we have to take our initial position, and we're going to add the displacement. So our initial position was -5. Displacement, we know we're going to integrate velocity. But again, the important thing here is since our initial position was at time t equals 0, that 0 has to be the lower bound of my integral. My upper bound is going to be 3. And now we're just going to go to the calculator. So let's see, I'm going to have -5 plus, my integral is math 9 from 0 to 3. And again, I'm just going to put in that same function we had stored. So we're going to go into vars, over to yvars, whoops. I got out of there somehow. Yvars, hit y1, and then we're going to do dx. And we get -1.760. Now again, you'll notice I'm going to 3 decimal places. That's an AP standard. We always go to 3 decimal places unless it's specifically you're instructed to do otherwise. All right, let's see. Now we're asked to evaluate 2 specific integrals, excuse me. So we're going to do the integral from 0 to 3.5 of v of t dt. Again, I can go right to my calculator for that. So math 9, I'm going from 0 to 3.5. Let's go grab our function. And we're going to get 2.844. Now it asks us to interpret the meaning of this integral. So if I'm just integrating velocity, we're going to say this integral, so 0 to 3.5 v of t dt, represents the displacement of the particle from t equals 0 to t equals 3.5. And again, you can see I did not put any units in there because there's no units given to me. Okay, now for the second one, 0 to 3.5 of the absolute value of v of t dt. Again, I'm going to go to my calculator and I'm going to do math 9, 0 to 3.5. My absolute value is going to be in my math menu here. So I'm going to do math, go over to number, and number 1 is absolute value. I'm going to grab my function again. And dx, whoops, I put that in the wrong place, over here. And that gives me, when it's done calculating it, I can see sometimes this takes a sec. Okay, 3.737. And then hopefully, right by now, we recognize that this absolute value, if I integrate the absolute value, it represents the total distance traveled by the particle. And I could say over the interval from 0 to 3.5. Now, I only changed up how I said the interval because all of those are acceptable. You can kind of find the way that makes the most sense to you, but they all mean the same thing and would be acceptable explanations in terms of conveying that interval. All right, the last part now says a second particle moves along the x-axis with position given by this function. They want to know at what time t are the two particles moving with the same velocity. So I want to know when are those velocity functions the same. So I can go ahead and find this velocity function. That's pretty easy. So x sub 2 prime of t is equal to 2t minus 1. And I want to know when is that equal to this velocity function we had here. Right? That's my question. I'm looking for the time when those are equal. So all I'm going to do is put those into my graphing calculator and find out where they intersect. So let's do this. We already have our first function, our first velocity function. Now I'm going to plug in my second one, which is a much simpler function, just 2x minus 1. And now I'm going to let my calculator do the hard work for me. It's going to graph them, and we'll just use the intersect feature to find that time. Now, it just so happens I had already set my window 1, 2, 3 from 0 to 4, which fits our window here. So I'm going to look for, it looks like this is the intersection point here. And I can change my window. Maybe I'll change my Y from 0 to 5 to be able to zoom in a little better. That'll sometimes help you locate that point a little better. Sorry, this is going to take a little bit for it to graph. And here comes the linear piece. All right, so now what I'm going to do is I'm going to do my second trace here. I'm looking for the intersect. So I'm going to put my curve close to that. You can see I'm on my blue curve. I'm going to hit enter. It's going to bring me to my red curve. I'm going to hit enter and then once more. And that's going to tell me they're intersecting at t equals 1.571. And again, I don't have units, so that would be my answer. That's where those velocities are the same. All right, so that is kind of like the three main ways they can present these problems to you. From a graph or a table like we had the other day, or from a function. So as usual, make sure you've got good notes on there, and then in practice you'll get a lot of chances to work with this. All right, thank you. See you in class.